Today's lesson is angles and triangles, and this goes with 10.3 in our textbook. Our goal is that we can classify triangles by angles and sides. All right. So, an acute triangle is a triangle that has 3 acute angles. There's a picture of an acute triangle. Not the only acute triangle out there, but it is an example of one. Sorry, smartboard trouble, as has been the case lately. You guys are accustomed to this. Oops, sorry. All right. Next, we have a right triangle. This is a triangle that has 1 right angle. This is evidenced by that little square down in the bottom right here. That lets you know that it is a right triangle. Anytime we have a right triangle or a right angle of any kind, for sure, it will tell you that, unless you're, of course, having to measure it. What type of angles are the other 2 in the right triangle? Well, obviously, I don't know if you guys know this or not. The sum of all angles is 180. If you don't know that, write that down. But if they all equal 180, that gives us only 90 degrees left to work with, right? So if we divide 90, if we have to split it by 2 others, we're going to have 2 acute angles for our other 2 angles. The only way it can be. Okay? All right. Our last type of triangle is an obtuse triangle. This is a triangle with 1 obtuse angle. And if we have an obtuse angle, we of course have to have the other 2 be acute. Okay, moving on to the slide I wanted to jump to a minute ago. We classify the triangles by their angle measures. Let's go this way. So if we have a 40, a 60, and an 80, this is an acute triangle. 45, 35, 100. This 100 is obtuse, making the full thing obtuse, except I can't write today. Okay, and last we have a 90, 76, and 14. This 90 makes it a right triangle. Okay, next, classifying triangles by their sides. An equilateral triangle is a triangle that has 3 sides with equal lengths. And these marks here tell us, those are equality side markings. They let us know that the sides are all equal in length. Next, we have an isosceles triangle. This is a triangle that has at least 2 sides of equal length. So you can see they only have 2 sides by their markings here and here. Those let us know those 2 sides are equal in length. And last, we have a scalene triangle. This is a triangle that has no sides of equal length. All right, moving on. We're going to classify these triangles by their side lengths. So we have 3 feet, 2 feet, and 2 feet tells us that this is isosceles. I-S-O, let's check the spelling on that, I-S-O-S-C-E-L-E-S. And we have 6 centimeters, 15 centimeters, and 18 centimeters. This is scalene. And last, we have 19, 19, and 19, equilateral. Oops. All right. Moving on. Find the lengths of the unknown measures in the following triangles. Let's do one at a time. Oops. All right. So we have 42, 42, and an unknown x. So we know, as we said earlier, that the sum of all the angles in the triangle have to equal 180. So we've got 180 plus equals 42 plus 42 plus x. So 42 plus 42 is 84. So then I subtract my 84 from both sides. And I'm left with my x over here. And 96 over here. So my x equals 96 degrees. Okay. And over here, oh, actually, before we move on, you can tell that this triangle is also isosceles. By the fact that it has two angles that are the same. So these two sides would have to be in equal measure too. Okay, so moving on, same idea, let's do a different color. 180 is equal to 40 plus 88 plus x. So 40 plus 88 is 128. My thing's not working. 128 plus x. Subtract 128 on both sides. So we get that x is equal to 52 degrees. And all of our angles on this one are different, so this is an equilateral. And that's not that important that you know all that, but I can tell you that. All right, moving on. This is a challenge problem. So, still knowing that the sum of all angles is 180. We have three angle measures of x plus 3x plus 10 plus 70. So now we're going to combine our like terms. X plus 3x gives us 4x, and 10 plus 70 gives us 80. All that's equal to 180. Subtract our 80 on both sides. And we get these guys canceled out. 4x on this side and 100 on this side. Divide both sides by 4. And x is equal to 25. Now, we're supposed to find the actual measures of each angle. So this one right here is 25 degrees. Now we have to substitute in 3 times x is 75 plus 10 gives us 85 degrees. Okay? All right. Moving on. Okay, so we've got the triangle inequality theorem. This is not on your notes page, so you need to write this down. Hopefully there's enough room on there. If not, grab a piece of loose leaf and add it to it. So, any side of a triangle is always shorter than the sum of the other two sides. So, this means if I add the sides together of any of them, it should be shorter than the sum of the other two sides. So look at this. Here I have 3 inches, 5 inches, and 7 inches. 3 is less than 5 plus 7. That would be 12. 5 is less than 3 plus 7, which is 10. 7 is less than 3 plus 5, 8. So this one works out. We've got our check mark. Okay. Let's go down to our next one. 3, 5, and 9. 3 is less than 5 plus 9, which is 14. 5 is less than 3 plus 9, 12. 9 is greater than 3 plus 5, 8. So you can see that that cannot work. This triangle is actually not possible to form. Okay, we cannot make that triangle. And if you need proof of that, we can play with some things in class and I can show you. But that triangle cannot be created. So this is an important thing to know. You'll have to be able to work with this in class. So that is the end of our lesson. Oh no, sorry, we've got to practice it. So can a triangle have the following side lengths? 4, 8, and 2. Well, hopefully you can look at this and say 4 plus 2 is less than 8. So this one can't happen. This 5 plus 6 is greater than 7. So that works. 6 plus 7 is greater than 5. And 7 plus 5 is greater than 6. So that works. And then finally, and this last one, 6 plus 8 is greater, no, sorry, it's less than 15. Therefore, this one does not work. We're done. All right, so I hope you enjoyed our lesson. If you have questions, make sure that you make note of them and bring them to class with you next time we see each other. Have a great day.